Good morning. I am Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. In this session, we are going to discuss about one of the previous question that comes under multitasking problems. So first, third year question. Outline the differences between preemptive and non-preemptive scheduling algorithms in real-time operating system. Here, if you look at the process, whenever I want to do some task, the task is created and assign some IDs to the task. Okay. The task is divided into sub-process or whatever may be. The process ID may be process P1, process P2, process P3, like that we are giving some IDs. Here various states are there based on the operation. So the first is called ready state. Okay, when our process is created, that is under created state. After creating the process, if it is ready for execution, that is called ready state. Whenever this operating system, real-time operating system contains task scheduler. Based on the scheduling algorithm you are following here, that will decide which process needs to be executed first among the multiple processes which are in the ready state, which are ready for execution. Once the process is scheduled, that comes to the running state. While executing, if the process is waiting for resources, then it enters into the waiting state. If the process is waiting more than the defined time, that goes to the blocked state. After getting the resources, again the process enters into the ready state. Again, whenever it is scheduled for execution, that is entered into the running state. While running, if the current process is preempted, then that enters into the ready state, another process scheduled for execution. After completion of execution, that process is entered into the completed state. These are the various states in the state transition. Okay. Now, multitasking. Multi means more than one, task means some work. So we are doing multiple works, that's the meaning. So among multiple works, the processor will do the one job or one task at a time. So which task will we do? The defined or scheduling, either preemptive or non-preemptive. If you look at the multitasking, there are different types of there. Cooperative multitasking means, suppose if any process is executing, another process is waiting for resources, CPU. This P1 is voluntarily release the CPU, then only process P2 get the CPU. Or whenever process P1 voluntarily comes to the ready state, then only process P2 is entered into the running state. That type of scheduling is called cooperation. Cooperation between process P1 and process P2. Next, preemptive. Means if any process, about process P1 is in the running state, process P2 in the ready state. If any new process P4 is entered into the ready state, or process P2 or P3, whatever may be, immediately P1 is suspended temporarily. Stop the operation of P1. And compare the process P1 matrix or parameter. That parameter may be less execution time, or priority, or time slice. Okay. Based on that one, P1 either be continuous execution or enter into the ready state, or P4 waiting in the ready state, or P4 is scheduled for execution. That is called preemptive multitasking. If any new process enter into the ready state, the currently executing process is temporarily suspended, and compare the currently executing process with the new process in different parameters. What we are comparing in the sense? Less execution time. Which one is having less execution time? Which process is having highest priority? Which process is having first in, first out? Okay. Based on these things, new process is scheduled for execution, maybe if it is highest priority or less execution time, and comparing with this one. That is called preemption. Again, P1 is entered into the ready state, P4 entered into the running state. That is called preemptive multitasking. Non-preemptive multitasking means after completion of P1, then only the scheduler checks the ready state, which process is scheduled for execution. Okay. There is a major difference between preemptive multitasking and non-preemptive. Non-preemptive means once complete the currently executed task, then only a new process is scheduled for execution by the task scheduler. But in case of preemptive, the currently executing task may be preempted by the newly entered task. So which one is better? In case of highest priority time, preemptive is better. Why? Because the highest priority task is waiting for the processor, means we are highest priority task is temporarily waiting, not complete the highest priority task. We require highest priority. First of all, execute the highest priority tasks. If you are not executing the highest priority task, means what happens? Some problems may be occurred. Okay. Non-preemptive means in case of starving occurs. Starving in the sense, if any process is having more execution time, that is waiting more time. Even it is entered into the ready state first. If the new process having less execution time than the new previous task is still waiting. How much time it is waiting in the ready state? That is the problem. That is called starving. That is the limitation of the non-preemptive. Okay, this is one example. Here, one of the problem is for processes P1, P2, P3. With arrival time is different. Burst time means execution time here. Different. So if you like the, take the graph. This vertical axis indicating processes. This indicating time. And again, process P1, P2, P3, execution time 5 milliseconds, 3 milliseconds, 6 milliseconds. So at the time of 0, what are the processes in the ready state? Ready state, running state, completed state, waiting state, or blocked state. The scheduling algorithm is SJF, shortest job, fast scheduling. In non-preemptive and preemptive, in both point of view, we can do it now. Okay. First, non-preemptive. At the time of 0, only P1 is available in the ready state. So, P1 is scheduled for execution. We are considering non-preemptive SJF, shortest job, fast schedule. In this point of view, keep in mind that one. So what is the P1 execution time? 5 milliseconds. Non-preemptive means once complete the currently executing task, then only new process is scheduled for execution. So its execution time is 5 milliseconds. At the time of 50 millisecond, so remaining process, at the time of first millisecond, P2 entered. At the time of second millisecond, P3 entered. Just for reference purpose. At the time of 50 millisecond, again, as per scheduling algorithm, the scheduler checks the ready state. What are the processes available? P2, P3. Okay. Among P2, P3, which one is having less execution time? So P2 is having less execution. So P2 is scheduled for execution. Okay. So its execution time is 3 milliseconds. So at the time of 8th millisecond, its execution completed. At the time of 8th millisecond, what are the processes available? P3 only available. So P3 is scheduled for execution. So P3 is scheduled for execution. At the time of 14th millisecond, or 6 milliseconds. Okay. So now we can calculate average waiting time, and he is asking only average waiting time. Okay. So first, waiting time for process P1. P1 entered into the ready state at the time of 0, and it is scheduled for execution immediately. So waiting time 0 milliseconds. Okay. Next, waiting time for process P2. Process P2 enter into the ready state at the time of first millisecond, and its execution is started at the time of 5th millisecond. So how much time it is waiting? 4 milliseconds it is waiting in the ready state to get the CPU. Next, waiting time for process P3. P3 enter into the ready state at the time of 2nd millisecond, and it is scheduled for execution at the time of 8th millisecond. So how much time it is waiting? 6 milliseconds. So the average waiting time is equal to 0 plus 4 plus 6 milliseconds by total number of processes. That is equal to 10 by 3 milliseconds. Means 3.33 milli. Okay, this is for non-preemptive shortest job first scheduling algorithm for this requirement. Keep in mind, in this requirement point of view only. Now, we can consider preemptive shortest job first scheduling. In this point of view, you can check now. So first, at the time of 0, in the ready state, what are the processes available? At the time of 0, only P1 is available. So P1 is scheduled for execution. At the time of first millisecond, P2 enter into the ready state. So since it is preemptive, it stops the current process execution and compare the remaining execution time of current process with the execution time of the new process. So P2 execution time only 3 milliseconds. P1 remaining execution time 4 milliseconds. Among these two, which one is having less execution time? P2 only. So P1 is preempted by P2. So P1 goes to the ready state, P2 enter into the running state. Again, at the time of second millisecond, a new process P3 enter into the ready state. So what is the remaining execution time of P2? Already total execution at 3 milliseconds. Already 1 millisecond executed. So remaining execution at 2 milliseconds. P3 execution time 6 milliseconds. So if you compare these two, which one is having less execution time? P2 only. So P2 continues its operation. Means up to 4th millisecond. Again, now at the time of 4th millisecond, here P3 entered. What are the processes in the ready state? So already P2 completed, so only P1 and P3 available. So P1 remaining execution time, already 1 millisecond completed. So remaining is 4 milliseconds waiting is there. And P3 execution time 6 milliseconds. So among these two, which one is having less execution time? Already one completed, 4 remaining, 4 and 6. So P1 is having less execution time. So P1 is scheduled for execution. So what is the execution time here? 4 milliseconds to up to 8 millisecond. P1 will be executed. Okay. Now, at the time of 8th millisecond, so P1 completed, P2 completed. What is the remaining? What are the processes available here? P3 only. So P3 is scheduled for execution. Its execution time is 6 milliseconds. So at the time of 14th millisecond, its execution completed. Now calculate waiting time for process P1. P1 is entered into the ready state at the time of 0 and it is scheduled for execution immediately. So waiting 0. Named. At the time of first millisecond, P1 is preempted by P2. And how much time it is waiting? 3 milliseconds. So total waiting time is 3 milliseconds. P1 is waiting in the ready state up to 3 milliseconds. Next, waiting time for process P2. P2 enter into the ready state at the time of first millisecond and it is scheduled for execution immediately. So its waiting time is 0 milliseconds. Now, waiting time for process P3. P3 enter into the ready state at the time of 0 and scheduled for execution at the time of 8th millisecond. So how much time it is waiting? 6 milliseconds. So average waiting time that is equal to, for this requirement, 3 milliseconds, 0 plus 6 milliseconds by 3 milliseconds. So that is equal to 9 by 3 milliseconds. That is equal to 3 milliseconds. So as the waiting time less means execution time reduces, speed increases. So in that point of view, if you compare these two scheduling algorithms for this requirement, if you follow the non-preemptive shortest job first scheduling algorithm, it takes 3.3 milliseconds. If you follow the preemptive shortest job first scheduling algorithm, it takes only 3 milliseconds. So for this requirement, the preemptive shortest of first scheduling is better when comparing with non-preemptive shortest job first scheduling algorithm. Okay? Because it takes less waiting time. That is 3 milliseconds here. Here, 3.3 milliseconds here. Okay? Like that, for particular requirement, we can compare all the scheduling algorithms waiting times and average turnaround times. We can decide in that requirement point of view which scheduling algorithm is the best. Okay. For this topic, we can refer the textbook is Introduction to Embedded Systems by Shibu KV, published in the 2009. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.